Number 39. Astrology, that unlikely and vague pseudoscience, makes much of the position of the planets at the moment of one's birth. The only known force a planet exerts on Earth is gravitational. Letter A. Calculate the magnitude of the gravitational force exerted on a 4.2 kilogram baby by a 100 kilogram father 0.2 meters away at birth. He is assisting, of course, so he is close to his child. Okay, so we're trying to find the gravitational force. This one's fairly straightforward. I'm going to use the gravitational force formula over here, where it says that I'll call this letter A, where it says that the gravitational force here is equal to the gravitational constant multiplied by the mass of one object, the mass of the other object, all over their distance apart from one another squared. So the gravitational force here will be equal to 6.673 times 10 to the minus 11 multiplied by one of the masses. So let's just say the baby comes first, 4.20 kilograms. Then the mass of the second object, which is the father here, that's 100 kilograms, all divided by their distance of 0.2 meters squared. All right, so this is fairly straightforward. Just throw it on into the calculator. So 6.673 times 10 to the minus 11 times 4.2 times 100, all divided by 0.2 squared. Oops, so hold on 1 second, guys. I accidentally cleared that out. Divided by 0.2 squared. I just had to round here a little bit, so I got about 7 times 10 to the minus 7. All right, so 7 times 10 to the minus 7. Should be around there, okay? And that is in terms of newtons. All right, so that will be the gravitational force between father and their child. All right, so let's take a look at letter B. And it says, calculate the magnitude of the force on the baby due to Jupiter if it's at its closest distance to Earth, some 6.29 times 10 to the 11 meters away. Okay, and then it says, how does the force of Jupiter compare to the baby, to the father, to this? Okay, so here's the mass of Jupiter down here on the right. It weighs approximately 1.9 times 10 to the 27 kilograms. Again, I'm going to be using the same formula, right? So remember, the force due to gravity between two objects is equal to the gravitational force multiplied by the mass of one object times the mass of the other object divided by their distance between one another squared. So the force due to gravity is going to be the gravitational constant, which is 6.673 times 10 to the minus 11 multiplied by the mass of one object. So let's just say, this is between the baby and Jupiter. So let's do the baby first. It really doesn't matter. The mass then of Jupiter second, which was 1.9 times 10 to the 27th. Okay. And then all divided by the distance between them, which was the value that they gave us, right? The 6.29 times 10 to the 11. And then we're going to square that, okay? So just throw this into the calculator now. So 6.673 times 10 to the minus 11 times 4.2 times 1.9 times 10 to the 27th divided by 6.29 times 10 to the 11th squared. And we get a value of 1.3 about, right? Oops, 1.3 times 10 to the minus 6. And that's in terms of newtons. So then it says, how does the force of Jupiter on the baby compare, right, to the... So what we can do here is we can simply do, a little division. We can take 7 times 10 to the minus 7th, divide that by 1.3 times 10 to the minus 6th, and we get about half, right? So it worked out to be about half as much. So the father has half as much, gravitational force as Jupiter does on the child. And I mean, I don't know about you, but that might be an argument for astrology, right? I mean, Jupiter supplies twice as much gravitational force as my dad did, so Jupiter must have more of an effect on me then. Anyway, thanks for tuning in, guys. Please remember to subscribe, and I look forward to helping you with the next question. Take care.